All right, hello everybody. Today we get to do a little bit of trigonometry. So the thing I want to start with is go over just the basics. And so what you're going to have is you're going to have sine, you're going to have cosine, which is just write COS for short, cos, and you're going to have tangent, and on that we write tan for short. Now, the little trick I'm sure you've heard before to memorize what goes what with these is SOHCAHTOA. I guess it's just catchy, easy to memorize, and so with that you're going to go SOHCAHTOA, and so you just remember that. And what you do with that is you then say, okay, SOH, and so that means sine is opposite over hypotenuse. So for sine, okay, so sine is opposite over hypotenuse. Cosine, what is cosine? Cos is adjacent over hypotenuse. And then tangent or tan, SOHCAHTOA, is opposite over adjacent. Okay, so this is how you take this little phrase you might have heard, SOHCAHTOA, and then turn it into sine, cosine, tangent. All right, so pause this, write it down if you need to, because I want to be able to do problems in a second, so I'm going to write this, but on the side and much smaller. So remember, so sine, SOH, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so let's keep that stuff in mind. Now, one thing I want to take a second and go over is how do you figure out what the opposite, adjacent, and hypotenuse is? So the easiest thing is always going to be wherever the 90-degree angle is, the side across from it, or in other words, the side that's not touching that angle. Notice that this side touches the top angle, touches the bottom angle, so it's across from the 90. So across from the 90 is the hypotenuse, okay? Most everyone, normally when they get this, that's not the one they mix up. What will happen is you'll start to mix up opposite and adjacent. So with this, you might be asking, which one of these is opposite, which is adjacent? And since whenever we're doing sine, cosine, tangent, we're never focusing on the 90-degree angle. We'll be focusing on one of these two angles. And depending on which angle we're using for this problem, that is what tells you where opposite and adjacent end up. So if we're using this angle, the side that's opposite is the only side not touching it. So it touches the hypotenuse, it touches this side, so the opposite side is across from it right here. And then the word adjacent really just means next to. So from this angle, this is the adjacent side. So from here, this is the adjacent side, this is hypotenuse, and this is opposite. So from here, if we had to do sine, we would do opposite over hypotenuse. If we had to do cosine, that's adjacent over hypotenuse. Tangent would be opposite over adjacent. Now, again, hypotenuse doesn't change. It's always across from 90. But if we're doing this angle, now the opposite side is that shorter side, the side across from it. And now the adjacent side is the side right next to it that's not a hypotenuse. So this would be the adjacent from that angle. So notice, depending on which angle you're using, that will change which side is opposite and which side is adjacent, okay? So now let me do a problem So let's do a problem here. Let's do a problem where we know that this is 46 degrees. We know that this side right here is 87. This is 90. And then it's H. This is G. This is I. And they want us to find this length X. So basically, they tell us that I is 90. They tell us G is 46. They want us to find the length of HG. So in other words, in this case, we're solving for X. What is X? So here's what you're going to do. Here's the angle that we have. And the way you approach this is you first start with the angle they tell you, and you ask yourself, what side do I know and what side do I want? Okay, there's going to be three sides. Of course, opposite, adjacent, hypotenuse. One of the sides they'll know, you already know, they tell you. One of the sides you don't know and you're trying to find out. And then there's a side you don't care about. You don't know anything about it and you don't want to know anything about it. So for here, this is the side we could care less about. They don't tell us anything and that's not what we're solving for. We're solving for X. So here's what we want to know, and here's what we already know. So let's take, based on this angle, why this angle? Well, it's because this is the angle we know. So from 46 degrees, we're across from 90. This is the hypotenuse. So that's the hypotenuse because it's across from 90. And then this is adjacent to 46. Notice, if the 46 was up here, then this would be opposite. But 46 is down here, so this is adjacent. Okay? So it's hypotenuse and adjacent are what we're dealing with. We know the adjacent, we want the hypotenuse. So look right here. Which one of these uses adjacent and hypotenuse? Remember, SOHCAHTOA, that's cosine. Cosine uses adjacent and hypotenuse. So what we'll do here, let's set up the problem. Cosine, and I didn't do it over here, but what you'll do is it's cosine, and whatever your angle is goes right there. What starts happening at this point in math, this is normally geometry, trigonometry, sometimes algebra 2, you start hitting these kind of problems, and a new thing shows up, and it's called theta. I know when you were in 6th grade, pre-algebra, whenever, and the X and Y came into math, you're overwhelmed, like, why in the world do we have to deal with the alphabet in math? Now we have to deal with the Greek alphabet in math. So congratulations, you've made it. So the reason we're doing this, though, is because we typically will use something like X, X, Y, and Z for the sides. So what we do is we use theta to mean angle. So the way that cosine works, it's cosine of theta, which is whatever your angle is, equals, and it's SOHCAHTOA, so C-A-H, cosine equals adjacent over hypotenuse, okay? So what is the angle we're using? Well, it's 46 degrees. So we're going to do cosine 46 degrees equals adjacent over hypotenuse. Adjacent is the one right here, right next to it. So 87 over the hypotenuse, which is up here at X. Okay, so we have cos 46 equals 87 over X. So what we need to do here, let's get X. We want X by itself and it's on bottom. So let's multiply both sides by X. What that does is it eliminates it over here. So it's not there anymore. And so the next line we have X. Okay, remember the whole goal right now is to get X by itself. Okay, so then let's divide by cos 46. Okay, and this is where we need to find the answer. Now, when we do this, the way you'll find this, and there's software that you can use on the computer, but we're going to use a graphing calculator, okay? Now, remember, this is 46 degrees. If I was being thorough, I should have kept the degrees here all along. So it's 46 degrees. It actually really matters. The reason is, so right now, if you have a graphing calculator, pull up the graphing calculator, and what you're going to do is you're going to press the button right here where my finger is. See that? It says mode. See where it says mode? You're going to turn on the calculator. You're going to press mode. And when you press mode, notice on top we have normal science and then engineering on bottom. And then you go down. And so you press the down button. You go down and it's highlighted where it says float. Go down one more. It's where it says radian. And you can go back and forth between radian and degree. Okay? So what you're going to do, you're going to go to degree. And then you're going to press enter. So now it's been switched to degree mode. Okay? So again, let's clear out of this. So one more time, you press mode right here, and then you go down to where it says radian and degree, and move over to degree and press enter so it's selected degree mode. Okay? That's the first step you got to do with this. So now that we do that, we just need to figure out 87 over cos 46. So on the calculator, we're going to do 87 divided by cos 46. Okay? And it's in degree mode, so it'll work out. So we get 125.2. For this assignment, it tells you to round to the nearest tenth. So we'll just say 125.2. So x equals 125.2. There's my answer, 125.2. Let's go ahead and do one more. So let me minimize this. Let me get another problem here. Give me 1 second. I'm pulling up another problem. So now we're going to have a problem where we're going to do, okay, good. This is a good one. Let's go. We have a right triangle. And this time, this is 7, and this is x. And down here is 52 degrees. Okay. I'm not going to label every point. The specific problem I'm using does, but I'll just make things faster and simple and not label every point. So here's what we have. Remember our sine, cosine, and tangent. What sides do we have right here? This is obviously the hypotenuse, but notice this is the one we don't care about because we're solving for x right now. And x is what we don't know and need to figure out, and 7 is what we already know. This is the angle you're using. So from this angle, if this is hypotenuse, the other side touching it is the adjacent side. Okay? And then across from it is opposite. Okay, so we have adjacent and opposite. Which ones of these uses O and H, opposite and adjacent? So, ka, toa. Go to tangent, T, T-O-A. Tan is opposite over adjacent. And right now, we have the opposite. We're looking for adjacent. So let's go ahead and set it up as tan theta equals opposite over adjacent. Theta is the angle you're using, so punch in 52 degrees. So tan 52 equals opposite, which is 7, over adjacent, which is x. Okay, this is just like what we did before. Now x is on bottom, so let's get it out of there. Okay, so you multiply the right by x, multiply the left by x. So we have x tan 52 equals 7. Okay, and then let's divide by tan 52. Divide by tan 52. And so we get x equals 7 over tan 52. So then we just take the calculator. Again, mode. It's in degree mode, which is what we want. And so I'm just going to do 7 divided by, and I also should have showed you on these calculators, you can see you have sine, cosine, and tangent. Notice that right across up there. So we're going to go to tan. So 7 divided by tan, and my angle was 52. So 7 divided by tan, 52. Press enter. So 5.5. So this one comes out to 5.5, and we got it. Okay, so again, x equaled 5.5. That's my answer right there. Let me do one more problem. Let's just go ahead and take the same type of problem. What I'm going to do now here will be a little bit easier in the problem solving. Let's go ahead. We're going to use the same 52 degrees, adjacent, opposite, but this time let's say, so I'll just make something up here. This time the opposite will be x that we need to solve for. The adjacent will be, let's just say 10. Okay, so if it's like this one ends up being a bit easier because when you set this up, so it's tan 52 degrees equals opposite, which is x, over adjacent, which is 10. Okay, now multiply both sides by 10. And so we get 10 tan 52 equals x. So let's just go ahead and plug that in. So 10, and then tan, and then 52, and we press enter. 12 point, remember rounding to the 10th, 12.8. Okay, so 12.8. So the missing side right here is 12.8. And there we go. Okay, so this is how you use sine, cosine, and tangent, and you use it to solve for a missing side. Okay, so email me or leave comments below if you have any questions.